For this tutorial, I wanted to take another look at solving trigonometric equations, and in particular I wanted to refer back to another tutorial I've done where I solve simple trigonometric equations, and then I wanted to look at a couple of examples of some what I consider to be more complex trigonometric equations. Now ideally a simple trigonometric equation is something that might look like sine theta is equal to 0.5 or cosine theta is equal to negative 0.75, something along those lines. Those are quite simple, so I would categorize these as simple equations because they involve a single trigonometric ratio, and even if there's a little bit of rearranging you have to do, they're pretty easy to do. They're linear equations, and so the steps involved here are basically the first thing you're going to do is you're going to find the related acute angle, or the reference angle. And the second thing you're going to do is you're going to apply the cast rule, which is going to tell you the quadrants. And the third thing you will do is then you will determine theta. Theta 1 and usually theta 2. And then there's one more step that we might have to do here, depending if it's, we might have to look for coterminal angles. I'm not sure if we need to do that under all circumstances. That's why I put a question mark there. It depends on the circumstances. So these ones are simple. So the question becomes, okay, so what are we dealing with? What do I mean by non-simple, or what do I mean by a more complex example? So let's go ahead and work through one of those. How about I give you something that looks deceptively similar to these, except for it's going to have a little bit more to it. So I'm going to make the numbers as easy to work with as possible. So let's go ahead and start with, I'm going to do something more along the lines of this. Sine of 2 theta is equal to, and just to make it a little bit more challenging, I'll make it a negative. Now this equation itself is actually not terribly complicated. I only have one trigonometric ratio. I've chosen a simple number. Yes, it's negative. The thing that adds the complication here is the 2 theta. So to deal with that, the way I recommend it is, wherever possible, whenever you have a complex trigonometric equation, turn it into a simple trigonometric equation, because then everything that you've learned about solving trigonometric equations is going to apply. So in this case, I'm going to use a trick that we've used many times before. This is perfectly valid mathematically. So I'm going to, in this case, I'm going to say let x be equal to 2 theta. And that's going to change my equation into sine x is equal to negative 0.5. Now we'll come back to this definition of x equals 2 theta later on. I guess there's one thing I should add. I'm going to apply the condition. We're going to solve for theta, where 0 degrees is less than or equal to theta is less than 360 degrees. Okay, so we're also going to make use of that. In most trigonometric equations you see, you're going to see some sort of restriction on the domain. So in this case, that's my domain, 0 degrees to 360 degrees. So let's carry on from there. Sine of x is equal to negative 0.5. The first thing I'm going to do, my first step, is I'm going to find what is my related acute angle. And the way I do that is I say the sine of the related acute angle is equal to, and I use the exact same value that I had here, 0.5, except for I take the absolute value. So I take the positive version of that, so that's going to give me positive 0.5. And so if I do that, then that means my related acute angle is equal to the inverse sine of 0.5, of positive 0.5. And for that, I end up with my related acute angle is equal to 30 degrees. And if you just want to check that on your calculator, of course, that's absolutely fine. But in this case, we've studied the exact values and special triangles, and so I know that the ratio for sine of 30 degrees is equal to 0.5. So I've done step 1. I found the related acute angle. So on to step 2. So let's go over here. Step 2 in this case is I'm going to use the cast rule. So basically I want to know what quadrants am I in. And so I remember my small cast diagram that helps me remember positives and negatives. In this case, my original value for sine x is negative. It's less than 0. So we ask ourselves, where is sine negative? Sine is positive in quadrant 1 and in quadrant 2, which means that sine must be negative in quadrant 3 and in quadrant 4. So now I know that my answer is in quadrant 3 or quadrant 4. Knowing that, I can now solve for, now remember, and I really want to emphasize this, we are solving right now for x. We abandoned theta when we made this switch, x equals 2 theta. So right now we're solving for x. So let's go ahead and do that. What does this look like in quadrant 3? In quadrant 3, we have 180 plus the related acute angle. So that gives me theta is equal to, see, look, I've already made that mistake. Such an easy assumption to make. We are not solving for theta. We are solving for x is equal to 180 degrees plus the related acute angle, which is 30 degrees. So that's obviously equal to 210 degrees. So that's my answer for quadrant 3. And then in quadrant 4, I end up with x is equal to, and how do I do quadrant 4? That's the one where we do 360 degrees minus 30 degrees, and that's equal to 330 degrees. Now, up until this point, since I made this switch over x equals 2 theta, everything looks the same. The only difference is we somehow have to come back here and deal with this 2 theta. But up until now, I've got my two angles, and everything looks the same as any kind of previous example with a simple solving trigonometric equation. So let's look at this last difference. And for this last difference, so I'm just going to divide this out again, just to show you, I want to emphasize that we're kind of moving on to another step. Let me once again take this 0 degrees is less than or equal to theta is less than 360 degrees. Well, if 0 degrees is less than or equal to theta is less than or equal to 360 degrees, but we made the change where x is equal to 2 theta. So we're not really interested in theta when we are trying to decide about coterminal angles. We're actually interested in 2 theta. So what do I do to turn this theta into 2 theta? I have to multiply everything by 2. So what I end up with is, so if I multiply everything, I'll use a square bracket here to represent that, I'm multiplying every piece of this by 2. Well, what's 2 times 0 degrees? That's simply 0 degrees. Less than or equal to 2 theta, less than 360 times 2 is 720 degrees. And that becomes interesting because with one more step, I think you'll see why this is an interesting thing. Hopefully I haven't done anything here that you object to mathematically. Now let's go ahead and make our substitution, which is that 0 degrees is less than or equal to, well, we said that 2 theta was the same as x, less than 720 degrees. That means that values for x can be anywhere between 0 and 720 degrees. So that 2 theta in our original equation has actually changed things quite a bit, because it means I now have to consider coterminal angles. So that's basically this line, or these two lines are basically saying I need to consider additional coterminal angles for x. Let's see if I have enough room on this page to do it. I don't have a lot of room, but I think I have enough. So what's another coterminal angle for these things? Well, I want to go up. I want to go higher, so I'm going to add 360 degrees. So that means I could also, and I might want to go back now, I'm going to label this x1, I'm going to label this x2, and I'm going to put on a value x3 And x3 is going to be 210 degrees plus 360 degrees, which is equal to 570 degrees. And x4 is equal to 330 degrees plus 360 degrees. And that is equal to 690 degrees. So you can see I have 4 answers for x. And our last step remaining is to figure out, well, what are our values for what are the values for theta going to be? Because the question actually wanted values for theta. So I'm just going to move some of this to the next page. So I'm just going to take the pieces that I want, which are here, and I will copy that. Let's see. And we'll move to another page, a new page, and I'll paste that. Hopefully it shows up good. So that's come with me. So those are just the values that I had for x1, x2, x3, and x4. So now I use the fact that, so recall, and what is the thing I'm going to recall? That x is equal to 2 theta. So what does that mean for theta? Because we're solving for theta. That means that theta is the x value divided by 2. So if x1 is 210 degrees, then theta 1 is equal to x1 over 2, which is equal to 210 degrees divided by 2, which in this case is 105 degrees. Theta 2 is equal to x2 divided by 2, which is equal to x2 was 330 degrees divided by 2, and that one turns out to be, what is that going to be, 150, 165 degrees. Theta 3 is equal to x3 divided by 2, which is equal to x3 was 570 degrees divided by 2, and that one's equal to 250, 285 degrees. And finally, theta 4, which is equal to x4 divided by 2. Sorry. And that is equal to 690 degrees divided by 2, which is equal to 345 degrees. Now take a look at those 4 values that I just came up with for theta. And I'm sorry, I'm going to have to go back to our previous page so I can refer to this. But our original question, I just want to highlight that part of it right now. Our original question said that 0 degrees less than or equal to theta less than or equal to 360 degrees. So when all is said and done, my values for theta have to be between 0 and 360 degrees. And if we actually take a look at our solution, our values for theta are between 0 and 360 degrees. All 4 of those values have worked out to be exactly what they were supposed to be. And the key to that was when we took 0 degrees less than or equal to theta less than or equal to 360, and we multiplied everything by 2. And so we ended up with 2 theta between 0 and 720, which means x is between 0 and 720. I can actually just slide down to that next page now. And so we ended up with those 4 values. So those are the 4 answers. So even with a non-trivial or a more complicated trigonometric equation, our primary goal is always to get it looking like a simple one. Use the steps that we've already learned to deal with a simple equation, and then make any additional accommodations. So in this case, the big accommodation I had to make was this 2 theta, which actually caused me to consider terminal angles or coterminal angles for x, which is the same as 2 theta. Okay, I hope that was clear enough, and I would encourage you to find some examples like this and work through them yourselves. When you see multiple angles in the equation, so that's a bit of a warning now, when you see something like 2 theta or 3 theta, that probably means you're going to end up with additional solutions made up of the coterminal angles.